Hello.
Hello.
Hi. Good evening.
Good evening.
hmm After so long time. Yeah.
Yeah, it's been a while.
hmm Okay. Okay. So we were studying the atomic structure. Yeah. Any
Yeah.
idea? Any idea about what we were studying in the last class?
Not really.
Mhm. No idea. Check your notes. Hmm. Did you get that is what you were studying in the last class?
Atomic structures. But we just started.
Hmm. But what we studied in that one?
Don't remember.
Hmm. Da- Dalton's atomic model we studied.
Uh,
Dalton's atomic model we completed. Yes, yeah, no.
yes.
Okay. So this was completed and we started to go for, this is what completed, and we started to study that is Thomson atomic model. You know, Thomson's atomic model, right? So what is the Dalton atomic model? Can you tell me any point of Dalton's atomic model if you are knowing any of the point? Total holiday, I think you spend it without studying. Yes, yeah, no?
Yeah, I don't remember. Um,
But you are supposed to study that one. If you are not studying means there will be the problems, right? We were if we, because competition is too high now, we need to be up to date. So Dalton atomic model, I said that is this is the completely failed atomic theory. What he said that is the atom is the smallest fundamental particle, but after the discovery of electron, proton, neutron, we got to know that atom can be divisible. Okay. And what he said that is atoms of same element are similar by mass. But what in case of isobars we find that is same isotope, same element can have the different mass. Like hydrogen is having three isotopes, 1h1, 1h2, 1h3. Similarly, he said that is atoms of different element are differ by mass. But in case of isobar, they are similar. Like potassium is 40 mass, calcium is 40 mass, argon is 40 mass. So this all the fail. Then it comes the Thomson atomic. This is Thomson atomic theory also based on the imagination only. There is no the practical proof was not there. Okay. So how the Thomson atomic model is given? This is also known as plum pudding model. This is also known as plum pudding model. This is also called plum pudding model. One more name is there, plum pudding model. What is the other name of the plum pudding model? This is also known as watermelon model. This is also called that is watermelon model. Okay. So this is all about the hypothetical model. Okay. Nothing was the proof about that. Okay. So let us have the point wise point we are going to study. First point. Okay. Atom is spherical in shape. Atom is spherical in shape. Atom is spherical in shape. So till today, this point is valid. Till today, atom is considered to be spherical in shape. So that point you need to keep in mind is atom is spherical in shape. Second point, all the electron, all the electrons, all the electrons are embedded. They are saying all the electrons are embedded in positive charge sphere. In positive charge sphere, positive charged sphere. Okay, just like what the point they are saying, just like seeds are embedded in watermelon. This is seeds are embedded in watermelon. This is the second point.
I
Watermelon,
didn't understand it. So the
watermelon.
electrons are embedded in positive charged.
Positive charge sphere. I'll explain this point again.
Okay.
Okay. Hmm. So the model is they are saying watermelon. So the model is also known as what? Also known as watermelon model. Can you be able to understand watermelon model? watermelon model. Okay. Next point, let's see. Third point. If you are going for third point, all the positive charge proton. They are saying all the positive charge proton. Okay. All the positive charge proton are present on the surface of atom. They are saying all the positive charge protons are present on surface of atom. Okay, that this is a hypothetical. Okay,
Are present on.
fourth one, all the positive charge protons are present on surface of atom. You can increase this statement on surface of atom. This is
That's wrong, right?
this is the wrong. This
Okay.
become the wrong. Okay, fourth point, number of, or you can say atom is neutral. He said that is atom is neutral. Atom is neutral as number of proton, and number of electrons are same. Atom is neutral as number of proton and number of electrons are same. It means number of positive charge and number of negative charge are same. Okay, so what it is, how it's going to be the structure, if you can see. Have you ever seen the watermelon? Yes, yeah, no.
Yeah.
So this is the watermelon, where he is saying that is these are the seeds are there right here. So how he manipulated the people that these seeds negatively charged seed. Okay, no, he said that is these seeds are negatively charged. Okay, here that is how he explained that is this is the negatively charged are there. So electrons are embedded in positive charge. You can see. Okay, and here is what the surface he is talking about. If you see the surface, because it is spherical now, so how can you be able to draw the structure? It can be like this. Here you can see. Okay, so this is this. Now let's try to draw this is positive charge, positive charge, positive charge. These are the positive charge. Okay, so this is the surface is positive charge. Yes or no? According to him. And
Yeah.
where is the electron? If you cut this one watermelon,
Right.
so electrons are embedded. So here we can write negative charge electron, negative charged electron, charge electron embedded. Okay, embedded in positive charge sphere, in positive charge sphere, charge sphere. Okay, and here is the positive charge proton. You can write positive charge proton, positive charge protons. Okay, protons present on surface, present on surface. Can you be able to understand this one?
Yep.
Okay, so these were the model of the, what you can say, that is Thomson atomic model. You can draw the another diagram also possible. Suppose this is the half we cut diagram we have done. Here you can see this is the sphere. When you are making the sphere, you need to make like this one, because this is the outward. Okay, sphere means it should come
Oh,
outward
yeah.
also.
Okay.
So where is the, if you are making the proton, so where we can make the proton? So positive charges are there here on the surface. These are the positive charge protons are there. Yes or no?
Yes.
These are the positive charge. Here also you can see the positive charge are there. Here these all the places protons are there. Where is the electrons? If you talk about electron, so electrons are embedded in the positive charge sphere. You can find that is electrons are embedded like this. Okay, so electrons are embedded just like the seeds are present in watermelon, so that this model become the watermelon model. Okay, so this is the first point is proved. Till today, this is the important point. This is the till time atom is considered to be spherical. Second point, what is atom is neutral. Atom is neutral. Here is atom is neutral. This is also very important. This is the application. Although this model was based on the, what to say, this model based on the observation, okay, imagination, but it explains so many things. Okay, so can you please make a note of it if you don't mind?
Yeah. Well, I wrote everything on this page, so just the next.
Okay, this one. Done?
Almost.
Hmm.
Yeah, done.
Okay, good. Now we are going to study the failure of this model. So I'm erasing this point. Let's have the failure. Okay. So failure of, okay. Thomson atomic model. Here we are going failure of Thomson's atomic model. So what can be the failure of Thomson atomic model? I asked, did you find any book for your this curriculum?
Yeah, I did.
You got the
But
book.
I don't know how to send it to you. I don't know how to send it to you.
Okay. You don't know. You
Which,
take the,
I can send you specific. I can take photos of specific
yeah.
chapters
Can you take the photo in cam scanner and then mail to me? Is it possible?
of the index or what? Of the all the different, but because in the, I mean, in the book,
Mhm.
they don't do all the things that are in the book.
Okay.
So only like what the professor picks.
That one only said. That one you
Okay.
said.
Okay.
Whatever you are supposed to study, that one only you share to me. You are having my email ID, na?
Yeah.
Yeah. Please do. If possible, today only you send me so that I will be also be able to help you more. Okay. So please,
All right.
you send me today only. So failure
Yeah.
of Thomson atomic model. What is the failure if you talk about this model? What is this one? This model, okay, could not explain what? Could not explain Rutherford. Here they are talking about Rutherford. No, alpha rays. Rutherford alpha rays is scattering experiment. Okay, is scattering experiment. Okay, what is mean by this one? Okay, let me take the diagram here. I am taking this one, thin gold foil. Okay, very thin gold foil. So this one, this you can see, this is the thin gold foil. This is the thin gold foil. Thin gold foil. Okay, this is foil. Now if you see this one, so here will be the atom will be there. Here is the atom is there. This is the spherical atom. It will be the diagram become. Okay, let me draw again. So this is the, if you find, this is the, nucleus, right? Nucleus and atom, okay, together are there. I'm taking one. Here is n number of atom is possible. I have taken one. Okay. Now
Okay.
what the Rutherford was doing here, you can see that is he's taking the no radioactive substance. Have you ever heard about the radioactive substance?
Yeah.
What is this?
I don't know what they are, but I've heard of
Uh,
it.
Radioactive substances means that generate what? Alpha beta gamma rays. Okay, alpha beta gamma rays. So what they did, they this substance, radioactive substance, generate what it is going to generate. I am writing alpha rays. Okay, although it is generating beta gamma also, but I need alpha rays only. Okay, so he taken these rays, right, and passes to the Nicol prism. Okay, he passes to the Nicol prism. Have you ever did the experiment with the prism? Yes.
No.
No. Okay, what the prism do now? Prism reflect the light. Okay,
Mhm.
okay, prism, when the light fall, it will reflect. But here in the Nicol prism, there is hole is there, right? Too much space is there. So what is happening in this Nicol prism? What is going to happen? Some rays are going to be passed. No, here is the rays are going to be passed. Now, see, when the rays are going to pass, so what he is going to observe? He is going to observe that 99% rays are passing straight here, and this everything is going to record on ZNS screen. He is going to record on ZNS screen. Little bit it is taking time. Okay, so patiently you please what? This is the ZNS screen. ZNS screen. What this ZNS screen do now? When the anything will fall on this screen, so it will glow. Getting my point?
Okay.
So
Oh,
they will,
yes.
so they will be able to observe the variation path of the rays. So you find that is most of the rays are falling going straight, right? Why? How he was observing? Because here they are glowing. Okay, so this way he was passing, continuously he was passing, and he was finding that is most of the rays are going to be straight only. And what he find, that is very few rays, very few rays, what that is deflecting. So you can see they are the straight passing. Now what you are going to find, that is some other color I am taking here. Some rays here, that is some rays are going to be deflect. Here you see this rays is going now here, it is going to be deflect. Here it is, it's getting deflect. Another possibility is there, one more rays is going to be deflect here. This is going to be deflect here. And out of, they are saying out of 2000 rays, one rays are returning back. One rays is going to return back on the path. Here it is returning back. Okay, it means what? Suppose if the atom surface, this alpha rays is if you talk about, this is the going to be positive rays. Getting positive rays. And surface, what the Thomson said, that is surface is positive charge. Yes or no? This surface is positive charge. What happened, that is if the positive will come close to positive charge, will it be repulsion or attraction? What will be there?
It should all be repulsion.
Repulsion.
So
Okay,
they all should have come back.
So what is this is expected, that is it should return back. Yes or no? This is expected that this rays should return back. Why? Because these rays are positive and the surface is positive. Getting my point?
Yes,
okay,
yes.
this is expected. This is the expected. But what is observed? If you see, if you are talking about observed, so you find that is every ray is passing. This all the positive rays, 99% positive rays are what they are doing. These are positive. It means these are the positive rays are passing. It means found. This is the found. It means positive charge is there on the surface or not?
No, not there.
Not there. Found in experiment, that is all the 99% rays are passing straight. It means whatever the Thomson model said, that is positive charge on the surface, this is all false. Yes or no?
Yeah.
Okay. So here we are in the failure. Let me write down in the failure. So this model could not explain the Rutherford alpha rays. Alpha rays means what? That is positive rays. Getting my point? Alpha rays means positive rays scattering experiment as what we will add here as all as 99%. I'm writing 99.9% positive rays passes straight to the atom, okay, passes straight to the atom. It means atoms. It means what? It means what? Can you tell me? It means
that there's no positive well, there's no protons present on the surface.
It means positive charge is not present on the surface of atom. On the surface of atom. As said by what? As said by who? Thomson.
Rutherford. Oh, Thomson.
Okay, no problem. So this model failed. Okay. Can you be able to understand?
Yes.
Please make a note of it a little bit faster.
Sorry.
We are lagging the time. Yes or no?
Yeah.
Acha, make a one more problem is what? Yeah, on the Sunday you are studying a little early. Here in India, the timing 5:30. Okay.
Oh.
So
Okay. Yeah.
what the problem? 5:30. Everybody goes to market on Sunday, right?
Oh, okay.
So I am facing the problem on 5:30. Can you be able to study on this time only, 9:30 on Sunday?
On wait. Today. So at 5 here now.
Same timing. I'm asking.
Can we do 1 hour later?
1 hour
At 6?
later, like you are talking about
Our time would be 6. Your 10:30, is that late?
10:30. It means night time. You are saying
Yeah.
like it is 9:30 here in
Yeah.
India. So you are asking 10:30.
Yeah.
No
But is that
problem.
late?
No
No,
problem.
it's
No problem.
huh, that I can do.
So that is the when the next class Sunday will be there. So we are going to study in Indian time 10:30, right?
I just have to ask my mom, but yeah, it should be fine.
Okay, you ask from the mom, and if
Yeah.
she is saying otherwise, you can change the date also.
Yeah.
Some other date you are picking, there is no problem for me. Nighttime, I am totally free.
Okay.
Okay. Is it okay? Did you wrote this one? It's completed?
Yeah.
Okay, thank
Yes.
you. Okay. This diagram we need to draw again. So what is the next model if you are going, that is, this is the Rutherford atomic model. Okay. Here is a Rutherford atomic model. So Rutherford atomic model is all about very easy, Rutherford atomic model, but it was very important model because the discovery, he discovered the nucleus. He discovered the nucleus. He discovered the nucleus. That is why this model become the very much important. NuCle nucleus. So that this model become very much significant in the field of the chemistry. Okay. So what he was actually, he was not, he was also doing some other things, but he discovered the atom property of atom and failed the Thomson atomic model. He was not doing any experiment about the atom. What he was doing actually, so the Madame Curie and Pierre Curie died because of the cancer. Okay.
Yeah.
Why the cancer? This alpha rays was there, alpha rays. This alpha rays means positive rays. Positive rays means that is harmful. They are not radioactive substance, are what they are very very harmful. Okay.
Yeah.
So that harmful, this is the harmful. Okay. Edge causes cancer. Edge causes cancer. Causes cancer. So what he was doing actually, what the Rutherford was doing, he was searching the device so that this rays should not fall on our body. He was searching the
No.
device so that this rays should not fall on our body. So for that, what he was doing, for that, what he was trying to do. Okay. So he was searching the device. See what the device he was doing. Okay. So he taking the substances like that, the alpha rays substances, he taken in the some closed container, and the container was the open from the one side. So its radiation is not going to spread. It is coming one side. Getting my point? Yes.
Yeah.
Okay. Now this all the radiation, whatever coming now, again he filtered with the prism. Again, what he did, he filtered the glass prism is there. This is called prism. This prism, if you know the property of prism or any no glass substance, so these substances, what they do, they reflect the radiation. They reflect. They are not going to come towards you. Getting?
Okay.
Okay. So all the radiations are not coming to you. Only few radiation are going to come towards you. Okay. Other radiations are going to return back. Okay. If suppose some radiation are coming here, it is going to return back. Only that radiation will pass which are going in the free space. Here they are going to be passed. Right. So what he was doing, now see, most of the these alpha rays are the stopped back. Right. So that if you are, and another, so that if you are standing here, so no rays will affect here, the rays is not coming to you, right? So if you are not falling on your body, so you are going to be safe. Okay. Then he was, what he did here, he taken the atom, one atom he was passing. So what he was finding, and this all the things he was recording on the ZNS screen. Here is the on the screen he was recording here. So what he was going to find, he was find that is most of the radiation are passing straight here. Most of the radiation are here, they are passing the completely, they are going to be a straight line. Okay, here, see you, they are going to be a straight line. Okay, here also you can see. But what he find during this experiment, what he find that very few rays here, this is the very few rays are returning back. So here you see the some rays are, they are saying some rays, very few rays, here they reflect on their path, you know, they are deflecting. Here also one more rays are getting deflect here, this side. Okay, and here that is one rays, one out of 2000 rays return back. Okay, this one. So they are the positive rays. Here is positive rays, right? So positive rays going straight, it means there is no positive charge on the surface, right? So what the observation? Okay, let me firstly next slide. So experiment, I am writing experiment. How the experiment was there? You see experiment. So experiment point number 1, passes, passes positive rays, positive alpha rays, alpha rays through the atom, through the atoms, through the atoms. This is the what experiment, right? Another things, by taking radioactive substance, radioactive substance. He took the radioactive substance, then what? Okay, and prism along with ZNS screen. I am also recording this video. I will share you. I will mail you, right? If anything is
Yeah.
ZNS screen to record the behavior. Whatever, to record the behavior of alpha rays passing through atom. So this was the experiment, passing through atoms. This was his experiment. Okay, it's all becoming the theoretical, but in the next class it all will be the numerical. Okay, so only today it will be the theory, complete theory, but next class we are going to start the electronic configuration. Complete will be the numerical based. Okay, so today you have to manage with the theories. So this is the experiment. Okay, now the next point, observation. What is the observation? Okay, 3 observation was there. What is the observation? First, okay, observation, 99.9% alpha rays. They are saying 90 alpha rays. Okay, or that is called, or positive rays. You can say all positive rays passed straight. Okay, pass straight to atom. Okay. Second point, few rays, they are saying few rays deflected. Where? Few rays deflected from their path. Okay, this is the second point. Okay, third point, what observe? He observed on the ZNS case, very few rays. Here he was writing very few rays. Okay, here is, in some book you will find 1 out of 2000. Okay, some books they have written 12,000, but you can see your book, what is there in your book. So very few rays, 1 out of 2000 returned back on their path. This is the observation on GNS screen. So you may be able to understand. See, this is Rutherford experiment. What he did, this is the radioactive substance. This is the radioactive substance.
But
I
his
told you.
experiment wouldn't make sense, because if he expected for there to be protons on the surface of the atom, then none of the rays would have been on the ZNS screen. So then what was the point of the experiment if he believed Thomson's theory? Because then none of the rays should have come on the ZNS screen, right?
No, all the screen, almost all are coming, but expected what the Thomson was expecting.
Yeah, Rutherford expected that none of them should come on the screen, right? Because
Yes,
that's
yes,
what
yes,
Thomson
yes,
said.
yes, yes.
But if he expected that nothing would come on the screen, then why did he do the experiment?
That is what this is. Unfortunately, actually, he was not doing the experiment for the atomic structure. He was saying that is some people were the searching the nuclear chemistry, right? Nuclear chemistry or the radioactivity. So they were dying. So many chemists died because of this radiation, because of this alpha rays. Why?
Oh.
Because
Oh,
what
he
they
was
were doing, they were not using the shield. This all the experiment were observing. This all the being absorbed in the glass shield. This everything is absorbed in the shield only, right?
Mhm.
So they
Yeah.
were they were observing this all the experiment they were doing in the open. So all the rays are passing on the head, on the body. So what they are called, they become the blind. Immediately it will fall on your eyes. You become the blind. Immediately fall on a screen. You become the cancer. So they were dying. So Rutherford was doing something. He thought that is, if we stop the alpha rays, only will pass those who are coming the straight. Other he was filtered out. How he filtered?
Oh.
Firstly, he's closed. Firstly, they see the diagram. Here, this is the closed container. One side open. No, this is a closed container. Yes, yeah, no. This is closed container. One side open. So every side it is not radiating. It's not coming to our body. Secondly, he passes some. He taking this one. You can see Nicole prism. If the rays are coming here, na, this will return back. Okay, you return back. Where you are standing? You are standing here, where the rays are not coming. Getting my point?
Yeah.
So what he was observing, he was passing to the atom. So what he was finding in the nuclear chemistry, you are going to discuss about the nucleus only. Other chemists were doing the same in the physics. So what he find all the rays are passing straight. 99.9% rays are passing straight. Getting? So he concluded. What he got the conclusion. Let me write the conclusion. This is the 99.9% rays, positive rays pass straight to the atom. Few rays deflected from their path. Very few rays, 1 out of 2000 return back on the path. Conclusion. What the conclusion? See? Conclusion. Okay. Conclusion number 90. He wrote like that. You see, since 99.9% rays passed straight. 99.9%. That's not the correct. 99.9% positive rays in bracket alpha rays. Okay, alpha rays passed straight. Can you be able to understand my handwriting?
Yeah, I got it. I heard.
Passed straight. That is maximum. That is, they are saying maximum portion of atom. Maximum portion of atom is vacant. Atom is vacant. But my accent is very different than the your. How you are understanding this all?
I write it differently.
Means you are able to manage. You are able to manage. Na? Okay. You are compromising with the accent, huh? Indian accent.
No,
and
it's
American.
okay.
Okay, good. Okay. So second point, can you be able to understand 99% rays passing straight means maximum portion of atom is vacant, totally vacant, nothing is there. Can you be able to understand?
Yes. Yeah.
Second point, he said few positive rays gets deflected from their path. Few positive rays get deflected from their path. That is some positive charge is present, or some positive charge is present in the center of atom. Means they are saying if positive charge is getting deflected, it means something will be there in the positive charge will be there in the center. Yes or no?
Yes.
Okay. Second point, is it okay?
Yeah.
Okay. Since they are saying, since very few rays, very few rays returned back on their path, returned back on their path, back on their path, back on their path. That means we can write that means. What do you mean by that? Means volume of, that means volume of what? That is volume of positive charge. Positive charge in center is very small. Center is very small. Getting volume of positive charge in center is very small. This is very small. Known as, what they are saying, known as what? Nucleus. Known as nucleus. Can you be able to understand? Known as nucleus. Yes, yeah, no.
Yes.
So he is discovering the nucleus. So other points are also there, but these are the conclusion. 3 conclusions are there. Remaining we will write. So what are there? These are the point. This is the diagram. So diagram, you can take the pic. Otherwise, I will share you the pic. What you want?
I drew it.
You already drawn.
Yeah.
This point, experiment.
Yeah, I wrote everything too.
This one.
Yep.
This one.
Yep.
Okay, very fast. Okay. So other point. Okay. So that is postulates. I am writing the postulates. Okay. Postulates, other postulates of Rutherford model. Okay.
What does
Rutherford
postulates mean?
point, important points. Important point. Rutherford model. Some other postulate. 3 conclusion already we studied. Some other are there. What are there? First point. Atom is spherical. Same. Atom is spherical. Nothing is the atom is spherical. He also repeated the same. Okay. Second point. What is volume of? See the point. Very important. Volume of, okay, nucleus. Volume of nucleus is negligible as compared to volume of atom, as compared to volume of atoms. Okay. Third point, all the positive charge of atoms, all the positive charge of atom are present in the center of atom, in the center of atoms in a small volume, known as what? What we will known this? Nucleus. Thank you. Okay. Fourth point, all negatively charged electrons. This is also very important one. This makes the Rutherford model fail. All negatively charged electrons are continuously revolving around the nucleus.
That's wrong.
This is not the wrong, but reason he did not explain. All the negatively charged electron continuously revolving around nucleus without wasting energy. Okay. So these are the point of the Rutherford atomic model, for 3 backside and 4 here. Okay. But how this model failed, that we need to explain. So if you completed writing work, I'll write in the failure of this model. Completed writing?
Yeah, you can. Yeah.
Can I erase this?
Yes.
Okay. Now failure. failure of Rutherford model. Rutherford model. Okay, Rutherford model. Now, what the point about failure of Rutherford model? What you are going to say about the Rutherford model? How this model is going to fail? So suppose if anything is getting displaced, yes or no? So what you will say? That is the work is done, yes or no?
Yeah.
If suppose a marker is there, marker, I am taking up and making down. So displacement is going on means I am doing some of the work I am doing. If there is no displacement means no work, right? So anywhere there is displacement, there is work, yes or no?
Anyway, yes, yes.
Displacement will work. Second point, if I am doing work, so energy is required or not?
Yes.
Means loss of energy is there. Suppose car
Yes.
is running from here and there, so it means car is running here from there. So it means what we can say, it energy displacement is there means car is doing the work.
Yes.
But what it is using? It is using the fuel. Yes or no?
Yeah. Yes.
Energy is being used. So what Rutherford was doing, Rutherford saying that is the nucleus, nucleus is there. Okay. So nucleus is there. Okay. So he was saying that is electrons are continuously revolving. Okay. Electrons are continuously revolving. Okay. Here they are, the electrons are there. Continuously it is going to revolve in the here. Okay. But continuously revolving, electrons are continuously revolving. But you tell me if it is revolving, so work is being done.
Yes, work is being done.
Energy is going to be lost.
Yes.
So what is expected? What can be expected diagram? Expected, if expected diagram. What is this one? Expected diagram. So means it is nucleus. So initially the electron are revolving here, but slowly, since the energy is being lost, the size of the cell will be decreased. Size of the cell will be decreased. Okay, size of the cell will be decreased. Yes or no? Here it is going to decrease because this is the loss of energy. If energy is more, means that it is revolving very far away. So this is, so slowly electron will reach here, electron will reach there, electron will, and finally electron will fall down in the nucleus and atom will destroy. Plus and minus combined, it will, atom will destroy. But expected, this is the expected diagram. Never observe. This never observe. Never observe. It means this is continuously revolving. Okay, electrons are continuously revolving, but from where? It is getting energy, from where it is getting energy to revolve was not explained. So this model failed. So this model what? Failed. Yes or no?
Yes.
Can you be able to understand this?
Yes.
Okay, make a note of it.
Okay. I just don't understand why the so the further away the electron is from the nucleus, the more energy it has, right? Okay.
That the next portion we will explain. We have to study so many model. Okay, it is explained by above. So later part it will come. Okay. Some points I will add on. Firstly you write down this one. I will add some more point in this Rutherford model. Some point I skipped out. Little bit going faster. Is there any problem? I'm going
No,
little faster.
it's okay. It's okay. More energy.
Electrons are continuously revolving, but from where it is getting energy to revolve was not explained. So this model failed.
Okay.
Got it? Okay. Some point I'm adding here, the fourth, I'm adding some fifth point. Please write down this, the fifth point also. Okay. if you are having a space, otherwise you can write in some other places. Fifth point. What the fifth point? Electrons revolve. Electron revolve on circular path without wasting energy. Without wasting energy is known as orbits. What is known as? It is known as orbits. Okay, so that is circular. If anyone is saying circular path, so if the path is circular, that is circular path is known as orbit, because Earth is also having the orbit. It is revolving around the sun. Yes or no?
Oh yeah. Yes.
Okay. So this point also please add on somewhere. The point number 5 added.
Yeah, added.
Okay, thank you. So let me go for the next point. What are the next point? This is already over. Diagram also done.
Yes.
Okay. See, now failure also. Now next one is coming. Bohr's atomic model. Okay. This model. Okay. This model given to explain. G is, it will be the smaller letter. This model given to explain what? Explain the failure of Rutherford model. Okay, Rutherford model. That is it explained what it is going to explain. That it is explain stability of atom. Because in the last model, you see, last one, electron was supposed to fall in the nucleus. So if the electron is falling in the nucleus, so atom will destroy. Yes or no?
Yes.
So that it is this model do not explain the stability. It means Rutherford model do not explain what? Do not explain the stability of atom. Yes or no? Stability.
Yeah.
Okay. So that is this model fail. Yes or no? So this model failed. So now what this model is saying, that is here Bohr's model is coming to explain the stability of atom. How it is explaining? He did actually, Bohr's did nothing. Okay, little bit he qualified the whatever the Bohr said in the same experiment, in the whatever the Rutherford said in the same experiment, he just modify the points and did nothing. Getting? Yes, sir. Like Rutherford said orbit. So he calculated the radius of orbit. Okay. Rutherford said that is the don't lose the energy. So he said that is the orbit is having the energy, right? Suppose how he explained. Suppose he said that is this is also known as planetary model. Earth is revolving around the sun continuously. Yes or no?
Yes.
Is it losing the energy?
No.
No. Same place, same, everything is same. It means the path on which it is revolving, that itself has energy. Getting?
Yeah.
Okay. Suppose I am running on the escalator. I am standing on the escalator, right? You must be knowing on the airport, you are using the lift in a escalator.
Yeah.
So on the escalator, you are standing. Yes or no?
Yes.
And you reach on the top. Yes or no? Or on the bottom.
Yes.
Did you do any work?
No.
No. You are standing. Stand still. Escalator was doing the work. Yes or no?
Yeah. Yes.
You didn't do. Similarly, electrons are not doing any work. That is, orbit itself is having energy. Yes or no?
Yes.
Yes or no? Similarly, so many planets are there, like Neptune are there, what moon is there, so many are there. They are revolving around the sun. Are they are losing the energy? If they are losing energy, they will fall down. Yes or no?
Yeah.
But that is not happening. Reason? Is it going to your mind? Are you be able to understand
yes.
this? Okay,
I understand.
good. So here, let me draw the diagram. He said that is nucleus is there, a small volume is there, all positive charge is there in the nucleus. All the point he repeated. Okay, but some point he added. You also try to draw this one. Will be able to write this point. Okay.
Should I also draw this?
Yes. Fixed energy circular path. Fixed energy circular path. Known as nucleus. Known as nucleus. Known as nucleus. Fixed energy circular path known as nucleus. Okay, this is the point. Okay, so they are having the fixed energy. This all is having fixed energy. Okay, so how they are going to represent? The first one is known as what? K orbit, then L, then M, then N, then O, then P. If you are numbered it out, so this is 1, this is 2, this is 3, 4, 5, 6. They are having the fixed energy. Okay, so they are the fixed energy circular path known as orbit, not nucleus. Sorry, yeah, known as orbits. Here is known as orbits. Known as orbits. Okay, known as orbits. Now, this is the point number 1. What is the second point diagram? So that is orbits are represented by. Orbits are represented by. How they are represented by? This is the K, L, M, N, O, P. Okay, so this is 1, this is 2, this is 3, 4, 5, 6. These are the representation of orbit. Okay, third point, energy order of orbit. Energy order of orbit. How is the energy orbit order? So K, then L, then M, then N, then O, then P. So this is the increasing. So last time you asked that is why the far away orbit is there, so more energy. So he explained. Okay, so increasing order of energy. Increasing order of energy. Can you understand this?
Yep.
Okay, very good.
But I still don't understand why.
The reason is what? That is the, you can say, the reason is what you can say. Too much reason is not there, but the larger the orbit size, the larger will be energy. This is what the
Is it because the force of attraction increases?
No. If the distance is, the force of attraction will decrease.
Yeah, that's what I thought. It doesn't make sense.
No. That is okay. What he explained, if the, because these are having the fixed energy, yes or no?
Yes.
So larger the size, larger will be energy.
Okay, yeah.
Can be able to understand?
Okay, yeah, that makes sense.
Okay. So these are the point. Okay. Here is the, this is the positive charge nucleus. Here is positive charge nucleus. Positive charge nucleus. Here you can write that is negatively charged electron. These are the negatively charged electron. Okay, negative charged electrons. Negative charge electron. Can you understand this?
Yes.
Okay, so these are the few points. Okay, these are the few points which we studied today. Okay, now we are supposed to write about this model. So these are the this model is given to explain the failure of Rutherford model. That is, explain the stability of atom. Okay, what are the point? Already we wrote the some point. Some point can we write here? Some point, some other point. Can I write?
Yes.
Okay. So that is first point. That is the all the positive charge, all the positive charge. Okay, charge protons. Protons are present in center. Are present in center. Present in nucleus. Simple. Present in nucleus. Okay. Second point is he said mass of electrons. Mass of electrons are negligible. Negligible as compared to mass of proton. Mass of proton in nucleus. In nucleus. Third point. Total mass of atom. Total mass of atom. More total mass of atoms in bracket neutron. In bracket neutron plus proton. Protons are present in nucleus. Nucleus. Okay.
Did they know about neutrons at the time?
At the time, after the Rutherford model, 1919 Rutherford model discovered. 1937 around, that is the neutron was discovered by James Chadwick. Okay, I'll teach you the discovery of. Otherwise, I will share some videos to you to watch the discovery of electron, proton, neutron. It is not there in your syllabus detail. If it is there, I will teach. Definitely, I will teach. Okay.
Okay.
So total mass of atom, that is neutron and proton, are present in the nucleus. Okay. Electrons are, they are saying, electrons are filled. Electrons are filled in various orbits by 2n square rule. By 2n square rule, where n is orbit number. Where n is orbit number. Where is n is orbit number. Can I change the page?
No, I didn't understand the last one. Electrons are filled in
various orbits by 2n square rule. I'll tell you this one. I'm explaining this this one rule. Can I erase? Can I go next page?
No, wait.
Where n is orbit number, that is you can write n is equal to 1, 2, 3, 4, 5. 1 means what? K, 2 means L, 3 means M, 4 means N, 5 means O. So K, L, M, N, O. This is. Is it okay?
Yeah.
Yeah. Can I change the page?
Yes.
Okay. Completed na? Writing work completed na?
Yes, yes.
Next one. So electrons in first orbit. If you are going electrons in first orbit. How many electron is going to be in the first orbit if you are going first orbit? First orbit means n equal to 1. Yes or no?
Oh, yes.
K cell or K orbit. Orbit is also known as cell. So that is according to rule. A by C according to rule. So according to rule, what is the rule? Is 2n square rule. So 2 into 1. Okay. According to rule, number of electron. So number of electron 2, 1 square. So total electron is 2 electron in first orbit, right? First orbit. How much will be in second orbit? If you are going in second orbit, second orbit means n equal to 2. So number of electron is equal to 2n square. So n equal to 2, we have to put 2 into 2 square. So how much will come? 8 electron in second orbit. Can you be able to understand?
Yep.
Okay.
Yes.
Can I change the page?
No, wait, please.
Okay, no problem. You are at least you are no copying. One more student I am having. Her name is Jainab. Okay. So what she don't write anything. What she said? That is, sir, you share the screen to me or share the video. I will write later on. 1 hour see studying and the sleeping mode only. But I don't know how she reply. I don't know. She reply very fluently. She reply immediately she will reply, but she don't write anything.
It's good. It's good for her. She remembers everything.
Maybe I don't know. Some students are having different mindset. Okay.
Yeah.
Third orbit. Tell me number of electron in third orbit. Number of electron in third orbit. How much will be there?
18.
18. Thank you. Good. 18 electron. Good. Fourth orbit. Fourth orbit.
16, 32 electrons.
32 electrons. Super. Fifth orbit.
50.
50
right?
electron.
Yeah.
Yes. Correct. So this is all about the Bohr's atomic model. Now that one, the in the next lecture we will study. I will check that this is there in your syllabus or not. We'll be studying the radius of Bohr's orbit. Okay, Bohr's orbit. If it is there, then okay. Otherwise, we'll go for the okay. And one more, you please remember me. This one is the we will study, that is okay. This you can be able to understand, no problem. Okay, radius of Bohr's orbit we will study in the next class, but not today, because if I will teach today only, you will start getting confusion. Okay, because this is the problem. Now it is completely, now it will come later part all about the numericals problem. So it will be the very much interesting. Till today it was the theoretical, right?
I like the theory too.
But you know the numericals also. Your mind is very much okay, very sharp mind. No problem.
Thank you.
So we'll be studying the other things on the next class. Okay.
Okay.
No. So are you be able to understand the concept whatever we are studying?
Yes. This is understandable.
So you firstly what you are promising to share the problems, right?
Yeah.
So you share the problems. Take the pic. Cam scanner will be there in your mobile. So you scan that and then send back to me, right?
Okay. Wait, can you just no, I think I'll find it. No, it's okay.
Yeah. Otherwise, if you can do the image also, you can share, right?
Yeah.
Okay. Bye. Take care.
Okay. Thank you. Bye.